My name is Skylar Terry, and I'm doing my week 8 video on the mechanism activity, and I was assigned the reaction number 15. So, moving to the first item, which is the identification of the electrophile and the nucleophile. In order to do this, I looked at the two compounds in the reaction, and I decided that the molecule that included the two iodine atoms would be the likely electrophile, and then the lithium acetylide would be the nucleophile because of its highly nucleophilic nature, with the lithium being paired with the triple bonded to the two carbon molecules. And iodine is also very indicative of a molecule being associated with an electrophile because it is a alkyl halide, which is associated with being a very strong leaving group. So therefore, and then also the respective nucleophilicity between the leaving group, which would be the iodine in the electrophile's case, and the triple bonded acetylide compound. The acetylide compound is clearly more nucleophilic, and therefore the leaving group would indeed leave in this case. And then the curved arrow mechanism is pretty straightforward because it is an SN2 reaction. It's bimolecular, which is the meaning behind the two, and the concentration of the substrate and the nucleophile would both impact the rate of this reaction. And this is primarily due to the fact that the alkyl halide is connected to a primary carbon, which is favored for a SN2 concerted reaction. So I decided on that for that reason as well. An SN1 reaction would be most preferable for a secondary or a tertiary. There would be some ambiguity more with the secondary carbon, but in this case it's pretty straightforward that a SN2 reaction would occur. And in a reaction like this, the carbon attacks the carbon alkyl halide in this case, and forms a very temporary intermediate where the iodine and the carbon are both connected, and then the leaving group leaves. But in short, that just means that this is a concerted reaction. The leaving group leaves at the same time as the nucleophile attacks. And as I was just saying, electron flow follows that the ions associated with the iodide atom will leave as soon as the electrons associated with the carbon atom on the acetylide, lithium acetylide compound joins the electrophile. And then specifically with this compound, I noticed that there were two potential sites of that the nucleophile could attack, and I've labeled 1 and 2 in the presentation. It is, let's see if I just move, yeah, there we go. There's 1 and 2 that you can see here, and I decided on site number 2 being more preferable because even though they are both primary carbons that the nucleophile would be attacking in this case, associated with those two alkyl halides, and they're both iodide atoms, but two site number 1 is subject to more steric hindrance than site number 2 for the reason of those additional methyl groups that are alpha, are the alpha connected to the alpha carbon relative to site 1. So therefore I decided on site number 2 for the reason of there being less steric hindrance, and that is more favorable for an SN2 reaction. Thank you for listening to my presentation, and have a great rest of your day.